11.4.5 Hypergeometric Distribution. Essential question. How can I find probability using hypergeometric distribution? Skill. I can use hypergeometric distribution to calculate probability. A class has 8 girls and 4 boys. If the teacher randomly picks 6 students, what is the probability that the teacher will pick exactly 2 boys? Let's refer back to the booklet to find the formula for this. We have hypergeometric. It's the number, the x is going to count as the number of marked individuals in sample taken without the replacement. We have the formula m choose x times n minus m choose n minus x all over capital N choose lowercase n. This notation right here is for combinations. So recall from before, NCR is n choose r. It also could be written out as n factorial over r factorial n minus r factorial. We could convert that from this formula to rewrite it. So if we wrote it out, it would be this formula in the red. Or if you want to just type it into Desmos after you identify your m, your x, your capital N, your lowercase n, you just plug it in with this. So let's figure out what these values are. M is the sample size. X is the number picked from the sample. That's going to be the 2 boys. Sample size is how many boys there are. It's going to be 4 boys. And then N is the total population. So it's going to be 12 students. And then N is going to be the number picked from the population. That's 6 students. Since Desmos reads x as like a variable for graphing, I called the x r in this one on here. So m is 4, let's plug that in. Capital N was 12, lowercase n is 6, and then the x is 2. That's 5 out of 11 chance of choosing exactly 2 boys. That's about 45%. Alright, let's look at this one with the gardener. A gardener has 13 identical looking tulip bulbs, which 6 will produce yellow tulips and 7 will become pink. She randomly selects and plants 5 of them and then gives the rest away. When the flowers start to bloom, what is the probability that at least 2 of them are yellow? On this, we use the same formula as before, but this time it says at least 2 are yellow. And there's 5, so it could be 2, 3, 4, or 5 are yellow. So we'd have to do the formula 4 times here. Or we could do it when it's 0 and 1 and then do 100% minus that probability. Then we'd only have to do it twice if we use a complement. Let's identify our values, m, x, capital N, and lowercase n. The sample size wants to be yellow, so that's 6 yellow. X is how many is picked from the sample, we're either going to do 0 yellow or 1 yellow. And then capital N, total population, is 13 flowers. And then lowercase n, they picked 5 flowers from the population. So we're going to do this formula twice, and then it's going to be 1 minus those. Let's plug that in on this paper. So 1 minus NCR of 6 comma 1 times NCR of 13 minus 6 comma 5 minus 1 all over NCR of 13 comma 5. And then we'll also subtract when x is 0. From here, we'll put this into Desmos. Alright, so let's put in our values. 6 for M, 13 for capital N, 5 for lowercase n. The first x we're going to say is 1, the second x we're going to say is 0. So it's 32 over 39, also known as 82%. So it's about 82% chance of at least 2 of them being yellow. All right, answer the essential question. And then try the examples below.